Okay, and it's recording, so unmute yourself and go ahead and get started, Sherwin.
There you go. Okay, good afternoon, everybody. Aluminum composite panels, or the industry knows it as ACP or ACM panels. Before we start, I'd like to thank or recognize some of the people that helped us through the years. I've been doing composite for the past 12 years, and these are my main resource. Retired field superintendents Mike Rodriguez, John Harbison, and soon to retire Ron Nickerson. My mentors, my resource is Bill, because I think Bill is the only PC who actually fabricated composite panels, right, Bill? Chris Almuela and
Yes.
Romy are my mentors. Everything I know now came from them. Carlos Haro is he used to work in the shop and he used to train people how to do composite. And of course, my protege, Daniel. Represent, Daniel. Okay.
Present.
Yeah, so Daniel will do some parts and I'll do some parts of the training. So Walters and Wolf composite panel system is 100% by our company. Like Walters and Wolf glass, we design, draw, engineer this product. We have two CNC machines, one in shop A, the other in shop B, to fabricate and assemble our own panels. And we field install every single one of them. Controlling the whole process makes it easier to manage. Okay, we discussed a bit about the material advantages and the design. How do we do shop and field fabs later on in the panel takeoff program, and some improvement we have over the years. Okay, so aluminum composite panel or sandwich panel, as you know, people call it, is a general term for panels constructed from two sheets of aluminum bonded to a core. So we have the first yellow right here is the primer, and then two sheets of aluminum. The inside is a plastic resin core, and the paint on top. Okay, it's not painted, but it comes in like a paint sheet that is bonded with the actual aluminum. Okay, here's a video showing how they manufacture the product. So everything comes in like aluminum sheets, very thin aluminum sheets. Yeah, the paint comes with it, the plastic core, and then everything's like bonded together and heated. That plastic right there is the protective coating on top. And then it comes out really nice and flat. Yeah, and for most of us, if you walk towards shop A, right, as we exit the patio, you can see like this stuck on top right after the door before reaching shop A, and that's all composite panels. Okay, some general classifications of composite. We are ordering materials from two vendors, Mitsubishi, which produces Alpolic brand, and Rainobond, which produces the Alucobond Plus. There's a different wide variety of color finishes, solid color, metallic, stone, wood, and prismatic. We usually use the solid color and metallic. Picture right here, the blue panels are from Lamb Project in Fremont. On the right, it's metallic silver color. Wood, we have used wood paneling finish before, and this is a 213 Iskran. Looks really nice on the lower right. Okay, in terms of thickness, it comes in 3, 4, and 6 millimeter, but we have only
So Sherwin froze up. Daniel, can you send him a text?
in terms of sheet size.
Looks like he's back.
Okay. Sizes 50 and 62 inches, and the height we can order as much as 196. Now they can produce as much as 210-inch long panels. Okay, some advantages of using composite panel. It has a large range of standard colors. The material is very strong, comparable to aluminum. It's visually flat. It rolls easily for rounded columns. It's very lightweight, lighter than aluminum panels. The panel is easily formed by hand, unlike aluminum panels that you need a machine just to bend or fold it. Composite can be formed by hand. Okay, so there's no extra processing involved. Panel, it comes in pre-painted. So unlike aluminum panel where we have to ship all the panels to another state just to get painted, here it's minimum transportation. We don't need to move the panels a lot. Fabrication, we only fabricate as needed. The shop right now can produce approximately 20 to 50 panels a day. So if the jobs got pushed out, we can always wait and fabricate as needed. So no overproduction. It's cheaper and fast to remake. A normal panel, if we are remaking a couple of panels, it will take at least 1 to 2 months just to fabricate them. In terms of composite, we can have it in 2 days. So no waiting. And the drops or the excess are easy to recycle. Some of the disadvantages are the surface are easily scratched. And this is true for most projects. We cannot weld corners. We can only attach them with fasteners. So the corners doesn't really come as clean. Folded edge are weak spots. So the face of the panel is really strong, but once you route it, the edges can crack, and stiffeners are recommended. Okay, here are some of the installation details that we have used over the years. We have two major systems, the wet seal system and the dry joint system. In terms of the wet seal, so the wet seal, the joints are caulked. Okay, so you cannot see what's behind it. So we usually use angles, staggered angles, or extrusion. On the right, CPS 2000. Oh, this is kind of old. Okay, the CPS parts. Oops. Oops. Go back. Okay. The dry seal system. So there's no caulking, so you can see between the joint. So our first system is using extrusions with alpolic plate, composite plate. right in between for the color, or on the right, it's the hat channel unitized system, or what we call the rain screen system. So the panel are screwed from behind using a hat channel, and then the hat channel makes it a unitized system. Okay. Now, how do we order composite sheets? So this is an example of sheet optimization. Okay, right here on the top, you can see a sheet 190 by 50. That's the size of the sheet. The outer line, okay, the outer border is the actual sheet size. And then you can see there's six rectangles, which represents each panel. So we can fabricate 6 panels in one sheet. The yellow part right there is the excess or the drop. Okay, so we're roughly using like 80% of the panel just to produce this one. So in terms of sheet takeoff, when we order materials, we want the most efficient sheet size. We want enough material for the project. We want to save as much money as possible, and we want to order at least the least amount of waste. Oh, sorry. Yeah. So yeah, least amount of waste. Okay, so step 1. This is really important. We need to finalize the distribution. Okay, because normally if we switch or we mix up distribution, it has a difference on what's this, the yield. And we can lose like more sheets. Okay, so we need to think about like distribution very early. We have to differentiate the colors. In terms of Fremont, the shop use glaze in or shadow box, we want them to be released weekly. We want to produce what the shop needs for the week. If it's going to Laverne, we want to fabricate everything together so we can save on shipping and transportation. In terms of field use, we want to optimize them per priority or per release. Step 2. Next is we want to estimate the panel area for every release. Okay, so we go by one, figure out the stretch out width and height and the quantity of every panel. At the same time, we estimate for the extrusion, the tube stiffeners, the fasteners, everything that we need to order. Okay, once we get all the sizes, we want to combine all the sizes and optimize them. And here it gets fun because we have to optimize it again to get the best yield. So I would start with the lowest sheet size, 150 inches, and then optimize it and get the yield. So on the right here where there's a circle, okay, oops. Sorry. Okay, it will tell you when you hit optimize, it will tell you the how many sheets you need and the yield. Okay, the higher the yield, we say what's this? We're using more of the panels, or we're saving more money. Okay, and then I will go through every 5-inch increments. So 150, optimize it for 155, 160, 170, 180 until I reach 195, and collecting all the data for the yield. Next, I will optimize it in 2 sheets, 100, 50 inches and 62 inches. And then I will go through all the possible sizes. I will try 3 sheets, 4 sheets until I get a nice big data. And then from there, we can choose like what is the best yield that we can use to order the sheet size. Okay, so here we figured that, using 190 by 52 and 190 by 62, we can have a yield of 88%, which is really, really good. 88, 89%. Okay, next, once we figure out the sheet size, we need to optimize it per release and optimize it per week. So right here is like how many sheets we need for every release. Okay, and then once Daniel fabricates and optimizes every release, he has to make sure that we're using the exact number or very close to what we have ordered. Okay, so at 85% yield, this 1,120 panel, 1,100 panel equivalents to probably $500,000. So if the yield drops down to like 75%, then that's an additional 50,000 just to order the materials. So we're saving money. Okay, and I think that's the first part. And then Daniel, are you there?
Yes.
Okay, can you continue on the fabs?
Okay.
I'll stop sharing.
Okay, cool. All right. I will be talking about field use panels, shop use panels, panel takeoff program, and shop work order. The field use panels, first of all, we need to review the panel scope. Then we prepare all the panel types templates from the template folder. Prepare all miscellaneous parts templates needed. Run the panel takeoff program for optimization, and then make the shop work orders. Down here, I put an example of a miscellaneous part. This is an angle for the attachments. On the right side, you can see the field use panels. These are a few of the most complicated ones that I've done. This is the 13 is grand right here. It's a circumference soffit panel, and then this was a guardrail for 825 industrial. I will show you this later on AutoCAD. Right here, the drill bit sizes on the CNC machine. The A drill bit is a 2mm size of knife. It cuts 110 degrees. The color in AutoCAD is light blue under the hidden layer, and we use it to create 90-degree miters. Drill bit B has a 3mm size knife, and then it cuts 155 degrees. It's a color magenta in AutoCAD under layer hidden 1, and we use it to make 135-degree miters. Letter C drill bit, it actually goes through the whole composite sheet. It's color white under the miscellaneous layer, and we use it to cut the whole panel and make holes for to drill. So on the right-hand side, you can see the actual cut to fold 110 degrees, A, B, and C. B is 155. The C you can see is cutting through the whole panel. I'm going to show you a quick example in AutoCAD. So here you can see there's I have a pretty simple field use panel. It's squared. So the first when we first start making a panel, we want to make sure that we're making a panel under the first quadrant of the X and Y axis, because that's where the actual CNC machine reads the panel. So we have to make sure we're in the first quadrant right here. When we start the miscellaneous line, the poly line, we want to make sure we start close to the origin, as you can see right here. So let me show you the legend that we use. So for example, hidden 1 right here, you can see this is the 45-degree fold that we use. It cuts all the way through the sheet. No, the white one cuts all the way through the sheet. This is actually to cut the panel. The circles are under the same layer, miscellaneous. Baby blue is a hidden layer. This is for 90-degree folds. And we put 2 views most of the time for the field use panels. This is the left side view, and then the top view. Every fold that we make, it decreases 1/32 from the actual size of the panel. So as you can see, this is the size that we need the panel to be, but when we fold it, it loses 30 seconds. So if it has two folds, it will be a 1/16, so 15/16 instead of 15 1/8. Same horizontally and vertically. The return leg is only one fold, so 1/32 instead of being 1/38, 1/11/32. So these are the basics. I'm gonna continue with my slides. Shop use panels, steps, review the panel scope, check Excel data from takeoff, copy the title block template from the templates folder, fill out the required information on the title block, copy and paste the corresponding code from Excel, run the script. All panel fab tickets are now automatically created. Print all fab tickets to PDF and send out for checking. Run the panel takeoff program for optimization. I'm giving you two examples right here on the right. Typical rectangle glazing, and then the shadow box. So I will show you how to make a title block template. First of all, we have all the templates inside the M drive, drafting panel templates, a poly panel folder. So you want to go ahead and copy and paste, copy the test and panel title, paste it on your working folder. Go ahead and open the panel title. This is how it would look. You need to fill out the job name, job number, drawn by, which is me, and then the project manager, and then 4mm composite, leave it like that as the standard. Paint finish and panel type. This is the test that I'm gonna be running right now for the presentation. So let's go ahead and fill everything up. Natural resources, and then job number. So my name, change the color. We use blackjack for the shadow boxes and natural resources. And the panel type, usually, it depends on the color. So either C1, C2, or C3, C4. Now save it and go ahead and open the test. Everything should be changed to like we changed the title block. So everything looks good. And save it before we run the program. So let me show you the next video. Okay, this is the, what is this? No, hold on 1 second. All right, this is Excel data programming. So now we have the Excel data from the takeoff group, all the sizes for the shadow boxes. Here we can see that there's a width and a height, so it's a rectangular shadow box. So we want to go ahead and click on developer, and then Visual Basic. Under project, double click this workbook. This window will appear. I have my code ready. Steve Watts, Sherwin, and I worked on this together. Right now, I have a typical script for my shadow boxes. So just copy and paste these. Here, you can see it says typical script, just for rectangular. The name of my shadow box that I use for natural resources is AN. This was a special shadow box because we needed notches on the top of the shadow box. So go ahead and run it, and then I'm going to show you. So if you run the command Lisp on AutoCAD, it will open all the coding that you have. I have these. I made it to create automatic dimensions to appear my shop tickets. I will show you where's the these all the panels that I have right now. Panel A is just rectangular, no notches. 1 inch return leg. This is the actual panel that we made together for the natural resources. All the notches. There was a lot of coordinates that we need to include. So that's why there you can see. Every time you change the name, it will grab the panel type from the script, from the code, and will create those panels. So that's the only thing you got to change once you have the code for Excel. You can see all the points right here. It will end right there. I have a typical glazing panel also. So now let's go ahead and run this. So save it. And click on macros. You can see the typical script, run it. Open your test, type in script. This will open a folder. This folder is actually Steve Watt's folder. That's where all the scripts are located at. I believe it's in Fremont, and then operations, drafting. So go ahead and click the date modified. That will bring the latest and greatest code. Open, and then it will be running all the sizes, and you can see right there's bringing out all the shadow boxes. And once it stops, you can go ahead and open the working folder just to make sure that you have all the shadow boxes that you needed. Back check the quantity so you're good. And then you can print to PDF and send it out for checking. Here you can see all the shadow boxes in the folder. Let me go ahead and get the other one. All right, this is the panel takeoff program. So we want to go ahead and open the panels to 2016 shortcut. This is how it looks. I want to open an existing project. This is natural resources, so we'll be using for the presentation. Double click the project. Before we do anything, we need to make sure that we're using the correct size that we order for the composite sheet. So you can see 160 width by 62 inches height. Go ahead and put 1,000, doesn't matter, just to make sure the optimization works out. Job number, job name. And then the panel allowance is the thickness of the drill bit we use for the CNC machine. Panel thickness is the actual thickness for the composite sheet. Default panel fab directory, we want to copy and paste the folder that we're working on. After that, we want to go ahead and edit the panel sizes. These are the old ones that we use, so make sure you delete those. And then want to get the new sizes from the working folder that we're using right now. I'm only going to use 4 because it takes a lot of time to optimize. So these 4 is grabbing them from the folder, and then I'm going to go back and optimize panels. So this takes a while, so I actually had to press stop recording, but let's see. So directional always, and then this will appear after it's done optimizing. You need to print this in PDF. So let me show you how it looks. So save it on your working folder. And that's how it looks. So let me press pause real quick. So we have a 63 quantity that we use of the 160 times 62 inch size of the sheet. There's 121 panels. You need to verify these, make sure this is the correct amount. 71% yield is not that good right now, but remember, I'm only using 3 shadow boxes just for the sake of the presentation. But up to 90, 95 should be really good. So, yep. Everything else is used for pricing and or from the start of the process. We don't need to know it right now, but yep. So let's see. After that, we want to go ahead and click the cutting info. This will bring out, okay, so yeah, cutting info, a list of the panels that we optimize. So there you can see quantity 5 of this size of this mark number, 41 of this size of this mark number, and the shop really needs these for packaging, so they can package by sizing or whatnot. This is really important for them. Then we go ahead and cutting list. The cutting list, this shows the actual composite sheet, how every panel will be cut. So you can see there's one panel, SB417, is this size. And then we need to cut 5 of these. And this is pattern number 1. This is the size of the sheet. So as you go down, you can see pattern number 2, we need to cut it 10 times. And then you can see the different panels over here. And we have 2 pages of these, so, you know, let's see what else. I'm gonna show you how this looks in AutoCAD before it's programmed for the machine. So let's close it and then create the sheet output files. So this is actually creating the files for the machine. Is reading it, and then after that, let's open it to see how it looks. So you can see all the lines that the machine reads. So right now, there's a hidden layer, which is the baby blue, and then the white, which is the miscellaneous, which is the that cuts all the way through the panel. Do you see the red line? That's a new line that the program created for the drill bit. So that's a miscellaneous layer. It actually offsets 1/8 of an inch because that's where the drill bit will be running through. You know that the drill bit is a 1/4 inch diameter, so this line is an 1/8 offset. So it's right at the center of the drill bit. I had to turn on my snap settings because somehow it was deleted, but yeah, this is what the machine reads. You can see it's 1/8 offset from the miscellaneous layer. Yeah, so that's pretty much. Oh, so right now I have inserted a block. This block on the construction layer, this is the size of the sheet. It's actually a little bigger, but that's fine. You can see how the panel is inside the sheet. You know how I told you guys that the panel needs to be on the quadrant number 1 by the origin. This is how you know that the panel is correct. The program is reading it. Otherwise, there will be an error popping out saying that, hey, something's wrong with your panel. You didn't draw it right. So everything looks good. And then we create the CNC files. These will create the actual file that we will have to be dropping inside the CNC machines from shop A, shop B. And then these are the files that we drop in. There's file B and file A. The file A is the old machine that we used to have. We got new one, so there's the file B inside the folders. So that's it for this one. Let me go for the next one. Shop work orders. I know that most of you guys know how to do these shop work order stuff. You go to this and that, but there's a really important step. So let's see, the PM dashboard. You go to PM dashboard, whatnot. Make sure you got the correct job, show work order, and then click add. Click add right there. Per Steve Watts, if you're making a composite panel, but you're trying to charge it to composite panel system, if there's no composite panel system, don't charge it to anything else, because then the hours will be charged to a different system. So just make sure you contact and email, I think it's Steve Polmis, I think that's his name, and ask him, hey, could you please add the system for composite panels? We need to charge 150 panels to this job. So that's all you need to know. And then fabrication, just put a brief summary and how many panels and for what priority. So I think that's it for the, I think, yeah, when you print out the shop work order, you're gonna need the number for the shop work order when we save the files for the CNC machine. That's how the shop guys find the correct work number that they need to work on. So you see this work number up here, the 10-565, and then all these numbers. So that's how we call the folder. Once we're done with these 100 SRT pieces, that's how they find it inside the CNC machine. Yeah, I think that's it for this one. Let me see for the other one. Composite panel show process video. So let me show you a video that Sharon found. Let's see. Making a stretch real quick for the panel, programming it. So this is how the guys carry the sheet on the CNC machine. Prepare everything to cut it. That's how it's routing. The aluminum extrusions, that's how they cut it and measure. So this is how the guys fold the panels. Attach the corner angles. The extrusions on the sides. They fasten into place. Once they're done, they package all the panels together. Make sure they put a separator or a foam piece or a cardboard just for protection. They don't scratch. And then ship to the job for installation. All right.
Mm-hmm. And
Do
so
you have-
that's from another company, but our
Yeah.
process is basically the same.
Yep.
Okay, before we go to the third part, is there like any questions?
Nothing popped up in the chat yet.
There's got to be questions. You just covered like a million things. Somebody has to know something at this point.
Come on, guys.
Save
by
it
the
for
way-
the end, I guess.
Yeah. Oh, I forgot. I'd like to thank Steve Watts, who developed the takeoff program that makes our life easier, and Zach, who helps us maintain and do the Lisp.
Thank you, guys.
Thank you. Third part, I will share my screen. So these are like some of the improvements that we did for the past, couple of years. I just want to share it because composite panel is it's a lonely process. I'm the only person doing it for like past 5 years, and then Daniel joined me. So there's only 2 person that is really doing composite for the company right now. So first off is simplifying the checking process. Before we would send out an open view of the panel right here that shows like how everything should look. So the program can read it, right? But when I send it out to the checker, it's only some checker that are really experienced that can understand how to fold the panels. And if Bill or Joe or Jose is busy, then we have to wait because no one can check the panels. So I'm like, since before I do it to understand the panel, I would like draw these, lines right here to show the profile. So this is when you have a detail cut or a detail section, it looks like this. This is the width if you look at the elevations. So this really helped me to produce this panel. So I'm like, why don't I just, add this view? So by adding this view, the panel are more understandable because as you look at the details, you can see all the dimensions. If you add all these dimensions in, I have a formula, you can get to this number right here. And then you can check like all the folds of the panel. It makes it a lot easier, okay? So with this, anyone now, even like an operator, can open or check the fabs. And that makes it like really easy. And we're surprised even the project manager can like add comments because they can see and catch like mistakes. And for the shop guys, this is easier. They can see like how to fold the panel, okay, looking at just the views right here, okay. This is an example of a bulldoze panel. So it, a lot of folds, but when you fold it, it should look like this one. The problem with composite, if you overfold the panel and then fold it back, the corner breaks and you have to basically throw out the whole panel and fabricate a new one. Okay, so this really helped us improve the quality of all the panels. Shop 2, we always, number 2 is the shop training. We always have problem in terms of training because we need, our shop guys to know how to read the fab ticket, do layouts, and measure angles. And the composite panel in our shop is like a revolving door of workers where, they come and go. So we are like constantly training people every week. Okay, just for them to like understand, and as soon as they get trained, they have to move them to another area. So we have to train like new people again. Okay, now why do we need training? It's because they have to understand the panel, and especially if you look at the clips right here, every single location of the clip is very, very critical. Okay, because the next panel, the clip of the next panel has to be 1/8 of an inch away from this one. So here is a typical example of a job we did before where you can see a complicated soffit panel, and then all these angles right here has to be placed exactly where we have dimension. And if they missed it or they, if the measurements are wrong, the field has to remove all the angles and reinstall them, which adds more work. Okay, so so what we did is we added on the fabs, on the programming, okay, we added holes right there. Okay, and we made use of the holes to create logic for the panel fabrication. Okay, so the okay, so here's an example. So we added all the holes. Okay, every time you fold the panel returns right there should be exactly how the angle should be, so that they don't need to measure angles. Okay, once they fold it and they see like two holes right there, they need to attach an angle. For the clips, two holes means they need to attach the clips right there. Okay, for different size angles, we have different hole location so that they won't attach a different angle where it should be. For extrusions, we have a hole that's 18-inch on center to attach one type of extrusion, and then a 24-inch on center hole layout for another extrusion, so they won't mix things up. Okay, every time they attach angles or the corners, they have to seal it properly. Okay, and then once they finish or they covered all the holes of the panel, that means the panel is completely fabricated. Okay, with this process, the shop guys doesn't need to measure angles, and they don't need to measure locations of every clip. So as soon as they see the holes, they know what to do. So it changed our training time for like weeks into like a day. And then they can get very confident as soon as they know that they're doing the right thing. So the quality of the product really gets better once we start doing this. Okay. Oops. Right. Okay. Number 4, distribution and packaging. So very, very important. If we got like thousands of panels in a building and we send them everything to the field, the field needs like weeks and lots of people to just sort out the panels to where they should be placed at or installed. Okay, so that's why we are very, very particular on the distribution. So this is a Muffet Place building. The entry portal has 200 to 300 panels arranged in nice checkered. Okay, so a horizontal cut right here shows that the panel is sticking out 3 feet, and you need 3 panels, okay, to form that bullnose shape. Okay, the horizontal has a different detail. It has the top panel and the bottom one right here. Okay, so we want the shop to package this as its own, so that when it arrives in the field, all the pallets or all the panels will on the release will just be like yeah, right here. Okay, so there's less transportation or less movement. Okay, everything they need will be on these packages. Okay, in the shop, okay, so the mark numbers is installed from left to right and from bottom up. So our instruction with the shop guys is, okay, so it's synchronized installation. So R10-1 here, R11-1, and R12-1, right? So that's the first one, R10-1 right here, and then it goes -2, -3, -4. So installation sequence is going up for the shop guys. So they will first fabricate R10-1 because they are the same size, so we want them packaged together, and they will pull out, the last number, which is R10-7. After they fabricate that, they have to put it at the bottom of the pallet, and then they'll go R10-6, 5, 4, 3, 2, 1. Okay, so that is how we communicate packaging. So when it gets out to the field, you have a nice panel package like the units. So whenever they open the packaging, okay, the first panel that they will see is the panel that they would install first. Okay, and then so goes with the R11, R12, R13. Okay, so fab sequence. Less sorting, really helps the field out. Number 5, standard stiffeners required. So before, we would wait for drafting or the calcs to tell us if we need stiffeners or not. And on some jobs, we missed it, and that's a big problem. And I'm glad that we added this as a standard right now. Every panel needs a stiffener, composite and aluminum. Aside from this, it makes sense that we care for the rigidity and the look of the panels. Okay, so we started adding a lot of like stiffeners on the panels, even though it's not cold out. Okay, so this is an example of that bullnose panel. So it's really hard to keep the shape of the panel with the bullnose right here. The angles can, it can open up. Okay, so we want to stiffen this one. So instead of ordering break shapes just to form this shape, so what we end up doing is we fabricated this shape right here out of composite panels. So PS1-1 and PS1-1S. So these are from, on the panel, wherever there's a drop, we just add this in. So it cuts together, so there's no waste material. Okay, so this basically comes out free. The PS1-1 is used at the top and bottom. As you fold them, and then you fold the panel, okay, it forms the shape and then a surface for the shop guys to screw on. Okay, and then the PS1-1S right here is in the middle. It comes with a return legs so that they can put sealant, and then it will glue on top of at the backside of the panel. Okay, that's why we were able to create a really nice, consistent fab all throughout the building right there. Okay, so we have one for here and then another one for there. So every time we see or we feel that the panel needs some rigidity, we will do something so that it would help the panel form the shape. Okay, number 6. Hide exposed fasteners. This is one of our early jobs. Samsung were on, okay, it's a nice dark colored panel, composite, okay, but we are on the details, it shows like exposed fasteners on the side going up here and then on the side right here. This is the typical detail where it shows that exposed fastener right there. And we're like, can we do something to remove it? So we played, basically like try to learn origami and fold the panel the best way in order for, for us to hide the fastener. And what we did, we came out with, something like this to fold the panels in. So you have to attach the channel with the countersunk fastener right there before you fold it, okay? And the shape of the panel looks like this one right here, okay? Second, we added like an extra fold because of the dark panel. Whenever you fold it, the corners right here where it comes together, it's shiny and it doesn't really look that good. So we have to add an extra fold so that it folds in so no one will see that corner. Okay, and so, that's how we achieve like all this really nice, looks consistent. It looks like an aluminum panel, welded and grinded corner. Okay, So because of that, like all of our jobs after that, we were able to like try to find ways to hide fasteners. Matilda, no, Mafet Towers alone, as we're ordering the materials, we need like 140,000 painted fasteners for the exposed, fasteners on the job. Okay, so we did, we added like a fold, and like you can walk around the building and you cannot see any. So that's really good. Okay, and so as these jobs, Gilead right here. This is Kaiser MOB, and Moffitt Place amenities. Okay, do we still have time? Oops.
You've only got about 3 minutes, Sherwin.
Okay, 3 minutes. Okay. This is Moffitt Towers. On the first two building, we use extrusions. Extrusions right here. John Harbison came back and said, "Hey, can we change this to a unitized system? Okay, to save field installation cost." So what we end up is have a unitized system attached with a hat rack, and we package them like a unit, and then they did like field installation. And on the first on the last three building, we were able to save 4 weeks of field time for 6 guys for every building, just by changing the design. So unitized panel. Okay, and then this is like one of the composite panel canopy design we did for Laverne Discovery. Okay, oops. Okay, future state. We want to make hopefully Walters & Wolff composite competitive. Okay, we want more jobs. We see that this is a win for the company every time we use composite panel. We want to explore better dry joint system, new designs. We want to find ways to make our panels more rigid so it will be more competitive. We want to standardize the shadow box panels as composite, as well as hopefully the glaze in and back pan, because it works for the shop that you just roll it and then we have the panels ready. We want to explore more on a unitized panel system to save on installation cost. And we want to standardize part using Lisp. So that's our future state. Questions? We got 1 minute.
There was just one question in the chat that was answered in the chat about, are the panels modeled in Inventor and then the drawings created in CAD? And Daniel replied to that one that that the CNC machine and the panel takeoff program don't read Inventor, so that it's being done in CAD.
So yeah, old school CAD. All the fabs are in CAD.
Okay, no additional questions for Sherwin and his team?
I guess no one's watching.
I think
No,
it's
we're here.
that
No,
we've-
good stuff.
Okay.
Good stuff.
we've covered so much material that
I know.
it's like, okay,
Stumped them. You stumped
fantastic.
them.
Sorry about that.
Very impressive. Because I remember working on some of this stuff before, and wow, what you guys are doing is pretty cool and pretty amazing.
Yeah.
Thank you.
So yeah, Daniel does all the fabs right now for composite, and I just do check. So yeah, it's a one-man team, right?
So when Steve Larson started at the company, I was teaching him how to fabricate composite panels with a tape measure, a pencil, and clamps and routers is how we used to fabricate panels.
Hand routers, Bill.
And routers.
Hand routers.
Yep.
That's hard.
Mm-hmm.
Yes.
So that's how they used to do it. By hand in the field, you have to route the composite panel at the back. And when you fold it, hopefully it's the correct size.
Yep.
Yep.
Come a long way.
Come a long way. Yep. Really great program, Steve.
Awesome.
Thank you, Daniel. Thank you, Sherwin. Great presentation,
Stuff,
guys.
Thank
Yeah,
you.
Yes.
good presentation. Thank you.
Yeah.
Thank you.
Thank you.
Good job.
Thanks, Cheryl.